This is a bearings question. It says B is 30 kilometers east and 20 kilometers north of A. So that is, let's just label this in, that's going to be 30 kilometers here. And that's going to be 20 kilometers that way. And C is 40 kilometers from B and 60 kilometers from A. So that's 40 and that is 60. What on earth is going on then? Okay, that's it. Calculate the bearing of C from B. Okay, people get this wrong all the time. C from B. So what the letter or place after from is where you're starting from. So it's from B. So at B, draw a north line. And then what we need to do is get the bearing. So the bearing, three things about a bearing: measure from the north. We've got our north line. It's measured clockwise, so all the way around to here. That's what we want to find in this question. Okay, so that's what we want to do. So we have a few things to do here first of all. And so the first thing we want to do is find a couple of angles. So what angles can we find here? We could find these two angles inside. I'm going to get rid of that wee line. We now know where the bearing is, but how do we actually find this? Okay, put a straight line across here, and I can find this angle in here. I'll call it theta. I can find that angle. I could also find this side. There must be an easier way of doing this, maybe not. I could find that angle theta. So theta, first of all, relative to theta, this is my opposite and this is my adjacent. So tan, remember, is opposite over adjacent. And then we can say that tan of theta is equal to 30 over 20. And we can use our calculator, tan to the minus 1 of 30 over 20 to find our theta. Okay, so if we do tan to the minus 1 of 30 over 20, we will get, I got 56.3099. We'll go to a few decimal places because we're going to have to use the wee bit more to get this. Okay, right, so that's just theta. So we've got that part. We also need to get this angle here. I'll call it alpha. To get alpha, how am I going to get it? Well, could get three sides of a triangle, and then I could work this out. So I'm going to find this side here, I'll call this x, and I'm going to use this wee right angle triangle here, the 30, 20, and then that x to do that. So that means x by Pythagoras, x squared is going to be 30 squared plus 20 squared. So x is going to be the square root of 30 squared plus 20 squared. And if I do that, I'm going to get square root of 30 squared plus 20 squared is going to be equal to, in fact, I'll just leave it as 30 squared plus 20 squared. See what that is. That was 1,300. So x is going to be the square root of 1,300. Leave it as that. That's perfect. And you'll see in a wee second, it'll make life a lot easier for us. Okay, so now we're looking at this triangle. So the triangle here, which was 60, 40, and then we know our x. So now we know that was 60, that was 40, and that was root of that, and that was our alpha. Okay, we can use our cos rule. Now the cos rule is given to you in your formula booklet as a squared equals b squared plus c squared minus 2bc cos a. You could also rearrange that to make cos a then is equal to b squared plus c squared minus a squared all over 2bc. Now that means the angle you're trying to find, which in this case is equal to alpha, is equal to, and alpha matches up with the 60, which means A matches up with, big A matches up with side small a. So here our alpha, first thing you do is put in the side opposite the alpha, so it was minus 60 squared, and then is going to be equal to, so cos alpha is going to be equal to b squared. I'm just going to write that as root of 1300, and that's squared, plus 40 squared, and divided by 2 times the square root of 1300 times the 40. And if we do that all on our calculator, so use your fraction button on your calculator do cos to the minus 1, then fraction button, and then you're doing your square root of 1,300, but it gets squared, so that's just 1,300, plus then 40 squared minus 60 squared, all over 2 times the square root of 1,300, and then times, was that 40, and then close your bracket. So you can get alpha is equal to, that seems too big, 104.0448 we'll go for. Okay, right. Now why I'm worried that looks too big. No, it would be big, I suppose. Your alpha then, yep, it is going to be a big bearing. Your bearing, remember folks, sorry, was all the way around from here to here. So it's going to be this bit here. First of all, it's going to be 180. That bit there is going to be 180, and then plus your theta plus your alpha. So we're just going to have to piece that together. So that means your bearing is equal to 180 plus 104.0448 plus, what was that up there, 56.3099. So if we just do all of those things, add those all together and see what we get. And what I got, and I'll give my answer to 2 decimal places. I'm not too sure what it was meant to be in this question. I'm going to go 340.35 degrees, and that's to 2 decimal places. And if you look back at your question, it's almost a full turn, so it makes sense for it to be that. I can't think of a quicker way of doing that question. I think there should be, but I cannot think of what it is at the minute, unfortunately.